Hi everyone. In this video we're going to continue our discussion of integration by substitution, but in this time we're going to talk about indefinite integrals, which is when you try to solve an integral that does not have the bounds and you're just really trying to find all the antiderivatives of a function. Okay, so let's again just do this by example. It's actually simpler than definite integrals because basically you can just forget about the bounds. Right? So let's do example 1. Compute the indefinite integral 2x squared e to the x cubed plus 6 dx. Okay, so this is not really an integral. That's why we call it an indefinite integral. The solution of this problem is not going to be a number. It's going to be a family of functions, right? So it's going to be a certain function, an antiderivative, and then you have to add a constant, and this constant can have any value. Right? So you've seen this before. Let's solve this problem by using U substitution. Right? So let me write the integral here again. Integral to x squared e to the x cubed plus 6 dx. All right, so again, there is one part of this integral which is pretty complicated. E to the x cubed plus 6 is a pretty complicated expression. But then you see here an x cubed, and outside you see an x squared, and that's a good hint that you should try to use U substitution, right? Because if you take x cubed plus 6, all of this together, you could just do u equals x cubed only, but it wouldn't help you as much. You can actually take u equals x cubed plus 6, all of it. So this is going to turn into an e to the u. And then the derivative of this is 3x squared, and you have this x squared here outside, which will combine with the dx and give you something good. Yeah, so let's work that out. So I'm going to call the new variable u equals to x cubed plus 6. So if you take a derivative, du dx is equal to 3x squared plus 0, right? Derivative of x squared is 3x squared by the power rule. Derivative of 6 is just a number, so it's 0. And so you can multiply by dx on both sides. You get the du, and actually let me divide by 3 as well. So du is equal to 3x squared dx, and I'll divide by 3 on both sides. So du over 3 is x squared dx. Right? And so if we apply the substitution here, this integral turns into the integral. All right, so this 2, nothing is going to happen to it. It's just a number. I'm going to leave it there. E to the x cubed plus 6 is going to turn into e to the u. And this x squared with the dx, x squared times dx, it turns into a du over 3. And before, we had to take care about what was going on with the bounds, but this is an indefinite integral, so you don't have to worry about it, right? So that's the difference when you have an indefinite integral. You don't have to do that change of the lower and upper bounds, right? So they're generally easier problems. Okay, so we can now just solve. This is an integral of an exponential. It's pretty easy to work out. Let me take this 2 over 3 here outside of this integral. Yeah. So here you just need an antiderivative of the exponential function. So this is 2 over 3. An antiderivative of an exponential function is e to the u, right? Because e to the u, you take a derivative, you get e to the u again. But an indefinite integral is the result of an indefinite integral is a family of functions, right? You can choose any value of a constant c, because if you take e to the u plus a number, the derivative of that is still e to the u, right? So you can't decide what this number is. So you just have to leave it there. C is any constant. Okay, and then here you can just multiply it out. 2e to the u over 3 plus, here you would get a 2c over 3, but c is any constant, so it doesn't really matter that you're multiplying that 2/3 there. You can just call it c again. It's a new constant. If you want, you could call it a different name, like c prime, and c prime is 2c over 3. But that's a little bit too much. The notation will get a little too heavy. You can just call it c again, right? 2c over 3, I'm going to call it c again. It's just any constant still. All right, and we're almost done. This is the indefinite integral here, the result of this integral. The problem is that we have a u variable here, and we don't want to solve, compute this indefinite integral and give an answer in terms of u. That's not good manners. All right. So the indefinite integral should be a certain function of x. We have this function here. You just use your formula for where u has to be, is x cubed plus 6. So here you're going to get 2 times e to the x cubed plus 6 over 3 plus a constant. All right, and that's the answer to this problem. So pretty similar to before, you just you can skip a step because your original integral didn't have bounds. It was an indefinite integral. So it makes it easier like that. But it also makes it trickier because I'm sure you know it's very easy to forget this constant. And it's important that it's here. Right? So an indefinite integral is just the family of all antiderivatives of this function. And you can always add a constant to get a new antiderivative. Right? So it's important that this number is here. So that's why you should pay attention when you're solving an indefinite integral problem. It's really remember that c there. Okay, let's do one more example to wrap this up. Okay, so example 2. Compute the integral of 1 plus square root x to the 5th power divided by square root of x dx. Okay, so let me write it again over here. Integral of 1 plus square root of x to the 5th over square root of x dx. Okay. Also, in these problems, I'm not going to say explicitly this is a definite integral or this is an indefinite integral. You just have to figure that out by looking whether the integral has bounds or not, right? So I just said compute this integral, and you see that it does not have bounds, and you go, okay, it's an indefinite integral. I'm going to need to remember that constant, right? Okay, so let's solve it using U substitution. Again, I mean, this one is a little bit more confusing, but let me try to walk you through it. This is kind of the most complicated part of this integral, right? There's a 1 plus square root of x, and then all of that stuff is being raised to the 5. And then you're dividing by root x. And the idea here is basically, it would be nice, so 1 plus root x, this expression that's inside of this power of 5, the derivative of this, of 1 plus root x, if you remember, the derivative of root x is 1 over 2 root x, right? So you see this 1 over root x here, multiplying the dx, it's the derivative of what's inside of this power, this 5th power, right? And it turns out that that's why substitution is going to help us in this case, okay? So you're going to create an intuition and an eye for these things, right? But you see a complicated expression, and you see, okay, this thing is being raised to the 5. It would be nice to be just a variable to the 5, so you could use a power rule, right? But it's not. It has this expression here. But the derivative of this expression is 1 over 2 root x, and 1 over root x is outside, right? And they can combine. But it takes a little while to develop this this I, right? So in any case, we're going to call the variable u 1 plus root x. you can take a derivative of this variable with respect to x now. Derivative of 1 is just 0. This is just a number, right? And the derivative of root x is 1 over 2 root x. Yeah. This is just a power rule, right? Because root x is equal to x to the 1/2. So the derivative, root x prime, is you just, the exponent comes down, right? 1 over 2, and then you subtract 1. 1/2 minus 1 is negative 1/2, which is 1. Negative exponents, they go to the denominator, right? So this is 2 times x to the 1/2, which is 1 over 2 root x, right? So that's why the derivative is just a power rule, but turning these square roots into these fractional exponents. Okay, so this is the equation we get for the du and the dx. I'm gonna multiply the dx again on both sides, and I'm also gonna multiply both sides by 2. Okay, so we're gonna get that 2 times du is equal to dx over root x, right? So here, if you first multiply dx on both sides, you get the du is equal to dx over 2 root x. Multiply by 2 on both sides, you get the 2 du is dx over root x. Okay, and this, so here's like, let's box our u sub. This is all we need. So this integral is going to be equal to the integral 1 plus root x to the 5, that's u to the 5. And then here you have a dx over root x on the outside. Dx over root x is 2 du. Yeah, just works out nicely like that. And now this is pretty easy to integrate. And again, because we don't have bounds, you don't have to change the bounds here in the u sub, right? So for an indefinite integral, you're not going to need to change the bounds. Okay, so we're here. So you just need to find an antiderivative for u to the 5. Let me take this 2 out. An antiderivative of u to the 5, that's just power rule. You add 1 to the exponent, you get 6, and you divide by that over 6. The same thing we used. Oh, we used before. It wasn't now. Okay, never mind. Right, so it's the power rule for anti-differentiation. Oh, this is not a definite integral. I almost made a mistake here. Caught myself before that though. So it's going to be 2, and then here's an antiderivative of, I took that 2 here out, right? Antiderivative of u to the 5 is u to the 6 over 6 plus a constant, right? Because it's an indefinite integral, so you don't know what the antiderivative is going to look like, right? You can always add a number to an antiderivative, and that's still an antiderivative of this function, right? So it's the result of the indefinite integral is going to be a family of functions. You can always choose any value for this constant c. Okay, and so let me multiply this 2 over. 2 times u to the 6 over 6. The 2 will cancel with this 2 in the 6 here, right? It's going to be a 3 now in the denominator. It's u to the 6 over 3. And then you would get a 2 times c, but there's no real point of calling it 2c, because c could be any number. Just call it c again, right? So multiplying c by a number, just call it c again. All right, so this is the antiderivative, and we are almost done. But the problem is in terms of the variables x, right? And you created this variable u. You shouldn't leave your answer in terms of this variable that you created. What is u is not even in the statement of the problem, right? You define what it is. So to give the answer, you put it back in terms of x, right? The answer to this indefinite integral in terms of x should be a function in terms of x, or a family of functions in terms of x. But that's okay. U is here given by this formula. So this is just 1 plus root x to the 6 divided by 3 plus c. Right? And that's the answer to this problem. All right, so that's it for integration by substitution. We covered indefinite integrals now. Last video we covered definite integrals. that should be enough to get you through most of the problems. It's just working through a lot of examples, developing this eye to see when to, what is the correct choice of variable to change the variables. But there's nothing more than this. All right, everyone. So I'll see you in the next video.